Okay, we're going to do another old exam question here from spring 2008. And the question is, which of the following statements are true about this series? And the first statement says the series converges because the limit of an equals 0 as n goes to infinity. And even though this part of the statement is true, that limit is indeed 0, the conclusion here is false, because you cannot conclude that a series converges if you find that the limit as n goes to infinity of an equals 0. We do have something called the divergence test, which says if this limit is not 0, then the series diverges. But you cannot conclude that the limit, if the limit is 0, that the series converges. So number 1 is false, because it has a false conclusion. How about number 2? Well, number 2 says the series converges by the ratio test. Now, in general, the ratio test does not work for rational functions. When you calculate the limit of the absolute value of an plus 1 over an here, if you have a rational function, that limit is going to be 1. Let's check it out for sure. The limit as n goes to infinity of the absolute value of an plus 1 over an. In this case, to get an plus 1, as in all cases, I replace every n in the formula by an n plus 1. And that's an plus 1, and then I divide by an. Now I invert that lower fraction, and I get that it's the limit as n goes to infinity an plus 1 times n to the 5 minus n squared by the square root of 3 over n squared plus 1. Now this again is a rational function, and this limit is just the limit as n goes to infinity of the leading terms in the denominator over the leading term in the leading term in the numerator over the leading term in the denominator. So the leading term in the numerator here, I have the highest term here is n to the 5, and the highest one here is n squared, so that's going to be n to the 7. And again, in the denominator, I have the highest term here is n squared, the highest term here is n to the 5, and that's going to be n to the 7. They have no coefficients. The coefficients are 1, well, 1, and so that limit is 1. And so there is no conclusion from the ratio test here. So 2 is false. Now, in general, for a rational function, the comparison test will work, and so I expect 3 will be true here. And so let's see. What happens when I use the limit comparison test to compare this series to 1 over n cubed? Well, I have to take the limit as n goes to infinity of an, let's call this one an, over bn, it would be 1 over n cubed, and that is the limit as n goes to infinity of n squared plus 1 over n to the 5 minus n squared times the square root of 3 times n cubed over 1. Now, of course, technically this just applies to situations where both series are positive, and that's certainly true for n large enough here. So the limit here, once again, we look at leading terms here, or in fact it's very easy just to calculate the entire rational function. It's n to the 5 plus n cubed over n to the 5 minus n squared times the square root of 3, divide by n to the 5 above and below, and you find that limit is 1. Now, unlike the ratio test, when you get a limit of 1 in the limit comparison test, then both series do the same thing. So since we know that this p-series converges, then both series converge. So number 3 is true, and the others are false. 2 is false, and 1 is false. So our answer here should be that only 3 is true.